Okay, example 2 of section 4, we're going to use graphs of rational functions. So here we have Young's rule. So if you have some adult medication, but your kid's sick and you want to give your kid the adult medicine, you could use this formula right here in order to figure it out. So if I take my adult dose times it by x, and x just represents the age of the child, and then I could use this formula to figure out how many milligrams I should give that child. So say if we have an adult who's taking a 200 milligram dosage, and our child, say, is 12 years old, can we figure out how much milligrams should we give of this medicine to this 12-year-old kid? Okay, so we could go ahead if we wanted to, we could plug that in. So now we have our equation. I guess we don't need to put that. Times x, and then we have 12 plus 12, and again, we'd plug in 12 in for x. And so then we could calculate what this would be. So we get 2400 over 24. Okay, cancels out. So 100 milligrams for a 12-year-old. Okay, so what if we don't know the age of the kid? Well, then we could just graph this, because that's what it's asking us to do, is to graph. It says use graphs of rational functions. So if we were asked to graph this, okay, and we want to use that same 200 dosage for the adult, okay, we plug in 200x over x plus 12. And so to graph this, we plug in a graphic calculator, see what it looks like. But we need to identify the horizontal asymptotes as well as the vertical asymptotes. So vertical asymptotes easiest, set the denominator equals 0, solve it. This one there's no factoring done, so we just get negative 12. So let's say we'll just count by maybe like 10, so like 10, 20, 30, 40. So negative 40, 10, 20, 30, 40. Okay, and then maybe 10's this way, 10, 20, 30, 40. 10, 20, 30, 40. Okay, and so negative 12 would be somewhere about right here, right? So we label that x equals negative 12. Horizontal, this is degree of 1. This is also degree 1, so they are the same. So I take the lead coefficient divided by the lead coefficient, so we get 200. So, oops. So somewhere up here, so maybe we should count by hundreds then. 100, 200, 200, 200, 300. So let's count by hundreds there, because we have this horizontal asymptote at y equals 200. So here we have the horizontal asymptote, y equals 200. Okay, now we could just plug in numbers to the left of this vertical asymptote and numbers to the right. So we could go ahead and do that. And we see that this graph, say we plug in 20. So if I plug in 20 here, 200 times 20 over 20 plus 12. So we get 4,000 over 32. So if I take 4,000 divided by 32, 4,000 divided by 32, I get 125. So 125. So if I plug in 20, 10, 20, I get 125. So somewhere right here. So I can't pass this line right here, right? So I know I'm going to approach it this way. And then it has to go down and approach it this way, right? Because I'm contained within there. All right, so those are boundaries that I can't go past. Okay, and then I can plug in, say, negative 20. Wouldn't that be negative 4,000 divided by negative 20 would be negative 8. So negative 4,000 divided by negative 8, and I get 500. So at negative 20, 10, 20, I get negative 500, so somewhere up here. So this one, I'm going down, I can't cross that one, and then I go up and I can't cross that vertical. So my graph looks something like this. So then I can estimate, look at this X as this would be my age, and my Y values are my milligrams of an adult dosage. So if I have 400 adult dosage, then my age should be negative something, right? Which it can't have a negative age, right? So my window is from, I can't have negative dosage either. So my true values that I'm really looking for is from right here up this way, right? So as you get older and older, you reach that 200 milligram dosage. So really you're just looking from this green spot, even though the graph is the blue. Okay, so that's how you could use it. You could plug in adult dosage, you could plug in the kid's age, and you could calculate it, or you could graph it all the way out to estimate where you want. And even though here's the whole graph right here, all we really care about is what's in reality is from this spot up, right? So that means no, probably less than 10 10-year-olds could take that adult dosage, right?